All right. So welcome back. We're back with our Fourier series, and we're gonna do examples. So last couple of videos that we have, we were just basically talking about different forms of Fourier series, and we have one general form, and from that general form, you can derive two other forms of Fourier series, and you can use them accordingly. So after doing that, let's do our first example. Uh, this is a very common example, an example which is widely used in electrical engineering discipline. Example is this: we have a rectangular pulse, okay, rectangular wave, and it's a periodic signal. So basically, what I mean to say, so this, right, this. It's a periodic signal and it's a rectangular signal, and we want to find out what are the frequency component which are present. See this, so imagine this. I'm looking at this in a time scope, in oscilloscope, and in oscilloscope this signal looks like this. But as we know, if according to the Dirichlet condition, if I have a periodic signal, definitely then I can use Fourier series to decompose it into sinusoidal and cosinusoidal systems. So that's the idea behind it, and that's what we're going to do. So we're going to pick up our basic form, which is f of t. All right, f of t is a naught plus summation n goes from 1 to infinity an cos 2 pi n f0 t plus bn sine 2 pi n f0 t. Right, that's the definition. So we know, so in order for me to find out what are the frequency component which are present in that rectangular signal, and then we normally know when I look at this signal in a spectrum analyzer, I would see that I would have multiple frequency component. But what components are there, right? So first of all, just a thought experiment, or just something to ask you: what type of a signal is this? Is it an even signal or is it an odd signal? So first of all, I know by looking at a signal, let's say this signal continues in negative direction and positive direction. So when I flip the signal, this is how I do it. This is how I remember it in these basic signals. So from the center, if I were to fold this paper, so this and this would be symmetric. This would lay on top of the other one, isn't it? So that means it's an even signal. And same thing, look at a cos signal. Is cos an even signal? Definitely it's an even signal. Why? Because cosine starts something like this. So if I from the middle, if I were to fold this, so consider this is a sheet of paper and this is on the other side and this is on the, if I fold it, this would lay on top of the other one. So this means this is an even signal. While sine, if I were to look at it, sine is something like this, isn't it? This is not an even signal. If I were to fold it, this would definitely not lay on top of each other, isn't it? If I were to just put it on top of each other, this would be actually canceling the other signal out. Why am I saying this? So it's not an even signal. Sine is an odd signal, because if I were to, from the middle, if I were to just fold this paper, this would not just lay on top of the other one. This would be actually laying opposite. Like if this is on the bottom, this will be on the top. This would not be symmetric. So very important distinction. All right, so this is the definitions. The first thing I need to calculate is my A naught. I know what my A naught is. Okay, A naught is given as, this is the definition. I'm basically just using the definition. 1 over t with respect to period f of t dt. Right, this is the definition. Right, this is the definition of A naught. All right, so what is my function? Let's say my function is this function. This is some waveform that has, my function is a. All right, are we good so far? And if I were to look at what would be this total distance from here to here, from negative t minus 4, t divided by 4 to t over 4, so that's the total distance of t over 2, isn't it? half of a period, isn't it? This is half of a period. All right, half of a period here, half of a period here. It will give me a complete period if I'm measuring it from here to here. If I'm measuring from this half of that peak, which is from 0 to t to the 4, or this is from negative t to the 4 to 0, 4, total is t over 2. So this and this would be a complete period. I hope you're getting the picture. Let's say this thing has some function a. All right. So in order for me to, so this is the first step I need to do. I'm doing it here. All right. So I know 1 over t. Just let's leave this for right now. Let's put our limits. What are the limits? Limits. So this, since is a periodic signal, this thing would start repeating itself. After one period, it will repeat itself. After one period, it will repeat itself. So this is actually going from negative t over 4 to all the way up to t over 4. These are going to be my limits. What is my f of t? F of t I have just given you as being an a d t. All right. So if I were to, so a is just nothing but a constant value. So I can just simply take this a out. Negative t over 4 dt. What is an integration of dt? Integration of dt is just simply t, where I'm taking a limit from negative t over 4 to t over 4. All right, I hope you guys are seeing this. We're going step by step in terms. So this is just going to be a over t. All right. So in place of t, I'm going to put t over 4 minus the lower limit t over 4. So this would be what? I hope you guys can see this. So this would be a over t. All right. This would be a over t. I hope this would be a over t. So t plus t is actually going to be 2t over 4. Right? So this is just, of course, this is just 1/2 because you have 2 on top and you have 4 on the bottom. And then a to the t, this and this will cancel out. So you will end up with your a naught would be a over 2. I hope you guys are seeing this. All right. So the DC component is just a over 2 if you were to take this process again. All right. Are we good so far? All right. There's also an intuitive way of looking at it. So let's look at it intuitive way. So by doing mathematically, we came to know my a naught is a over 2. It's right here. We just calculated this by putting in limits, and we know it's a over 2. But intuitively, if I were to look at it, this total signal is half, isn't it? Isn't it? What would be the average value of this signal would be? Okay. The intuitive way of looking at it is this. What am I saying is this. This is a complete period, okay? This is a complete period where you have a high signal and a low signal. Just intuitive way. If I were to cut this thing in half, all right, and then lay this half on top of this place where it does not have any signal, it's just 0. What would be that? So the average is actually is nothing, it's just an average of a signal. A naught is nothing but an average of a signal. I hope you're understanding it what I'm saying. I'm saying this, if this whole thing is A and this is half of the time and this half of the time is empty, by just looking at my rectangular signal, if I were to cut this in half and if I were to just lay on top of it, what is my average signal? Average DC, this is just going to be a half, isn't it? It's just going to, because if I were to cut it in half, I don't have anything here. I just put lay on top of this, I would end up with a half. This is another way, intuitive way of doing it, and this is another way you can also look at it. So we were calculating a Fourier series of a periodic signal which looks like a rectangular signal, and we just came up with my a naught value, which is a half, a over 2. All right.